Good afternoon. Today we will be talking about factoring by grouping. If you will take a minute and switch to the spiral review section in your composition book and hit pause and work these 4 problems, then we will reconvene and we will work on today's notes. Let's check your answers real fast. If you think about problem number 1, it is a polynomial. When you look at the square root of 19, the square root of 19 is a constant because there is no variable underneath the radical. Therefore, this is a polynomial to the 5th degree, and it is a trinomial because it has 3 terms. Number 2, when you simplify the expression, when you look at the powers, if you have x cubed and x to the 1, you add those 2 numbers to get the x to the 4. Y to the 4 times y to the 1 gives you y to the 5. And this is an example of the distributive property, and you just continue to repeat this process. Number 3, when you simplify the expression, remember this is like the distributive property twice. You're going to take the 2x, you distribute, and then we come down here and take the negative 5, and we distribute. You could have done this using the box method. Regardless, when you get the final answer, you should have 6x cubed minus x squared minus 37x plus 5. Number 4, what is the greatest common factor, or GCF, of this polynomial? Remember, numbers with numbers and letters with letters. So if you take 14, 7, and 42, the greatest common factor of those 3 numbers is 7. And then take the smallest power of every letter. So we have an x squared here, and that's the smallest power of x. And you have a y here, and that is the smallest power of y. Take a moment, flip to the note cards in the front of your composition book, and today we will talk about factoring by grouping. Why do we use factoring by grouping? You don't really need to write these on your note card, but just to give you a preview of why this is important. Factoring by grouping is really part of a bigger process as we continue our study on factoring trinomials, and this is really helpful when the leading coefficient is not equal to 1. And when factoring by grouping, you're really just going to apply the greatest common factor 3 separate times. So we are going to take the greatest common factor, take the greatest common factor, and then take the greatest common factor a 3rd time. So if you can do greatest common factor, this is not going to be that big of a deal. Take a minute, and we are going to write, and this may take like the whole front side of your note card, but we're going to write down the steps for factoring by grouping. So you do need to write all these down. If I go too fast for you, feel free to hit pause at any point. Number 1, check for the greatest common factor. If a polynomial has the greatest common factor, it is imperative that you factor out the greatest common factor before proceeding on. Step 2, the longest step. You are going to create smaller groups by grouping the first 2 terms and the second 2 terms. If the 3rd term is negative, you really should rewrite that as a plus a negative. So the negative sign goes with the second group. And we will do an example or 2 modeling this, and that will make more sense here in a second. Step 3. You now have 2 groups, so we are going to take the greatest common factor of each group. Step 4. You now have 2 terms. So you're going to look at the 2 terms, and if they have anything in common, this is the new greatest common factor. I want you to highlight that new greatest common factor. We will GCF out the highlighted common factor and get our final answer. And then I want you, whether you're doing the box method or the double distributive property, I want you to multiply your answer out and verify that you got the original problem. If you did not get all these steps written down, please hit pause and do that, and then hit play and proceed. All right, so we have the polynomial 3x cubed minus 6x squared plus 15x minus 30. So step number 1 says let's take out a GCF. So when I look at this polynomial and I look at the coefficients in front of each term and I look at the variables with each term, I see that there's a 3 in common. When I have a GCF in step 1, I will put the rest of the polynomial in square brackets because it kind of keeps it separate and you're just going to keep bringing the 3 down every single step. So if I divide the first term by 3, I'm left with x cubed. If I divide the second term by 3, I'm left with 2x squared. If I take the third term divided by 3, I have 5x. And if I take the fourth term divided by 3, I have a minus 10. So when I look at step 2, it says create smaller groups by grouping the first 2 terms and the second 2 terms. So as long as this is a plus right here, I can literally come in here and put parentheses around the first 2 terms and parentheses around the second 2 terms, and I am not changing the meaning of the problem. So step 3 says take the greatest common factor of each group. So important thing, this 3 has to continue to come down. It will come down with every step. So when I look at my first group, x cubed minus 2x squared, I notice that they both have an x squared in common. So I'm going to take an x squared from here. I'm going to take an x squared from here. And when I do that, x cubed divided by x squared is x, minus 2x squared divided by x squared is 2. When I look at my second polynomial, 5x minus 10, I see that both terms have a 5, so I'm going to factor out a positive 5. And that means I'm going to take a 5 out of each of these 2 terms, and that's going to leave me 5x divided by 5 will leave me with an x, minus 10 divided by 5 is 2, and that takes care of step 3. Step 4, there are 2 terms. So when I look at this right here, I see a term here, I see a term here. So if they have anything in common, that's going to be the new greatest common factor. So when I look at these and to see if they have anything in common, there's an x minus 2 here, and there's an x minus 2 right here. So what's going to happen? I'm going to bring down this 3, just like I've been doing. And then I'm going to GCF out my greatest common factor. So I'm going to take my greatest common factor, x minus 2, and I'm going to take an x minus 2 and divide each side by x minus 2. So if I look at this first term, these terms reduce to 1 and leave me with an x squared. These 2 terms reduce to 1 and leave me with a plus 5. At this point, this is your final answer. However, I do want you to check your answer. So if we come over here and we do the box method, this is x minus 2. This is x squared plus 5. So x squared times x is x cubed. X squared times negative 2 is negative 2x squared. 5 times x is 5x. And 5 times negative 2 is negative 10. So when I write that out, I have my 3 out front, and this will be x cubed minus 2x squared plus 5x minus 10. And if I look, that actually matches the polynomial that I have right here before I did my factoring, which means I have the correct answer. All right, this process takes a lot of steps, but if you will just go one step at a time, it is really not so bad. So let's tackle another problem. All right, let's look at the problem. 35xy minus 5x minus 56y plus 8. So again, we will always check for a greatest common factor. I do not have a greatest common factor, so I'm just going to bring down this polynomial. 35xy minus 5x minus 56y plus 8. So I'm going to create smaller groups. This time, if you look at this sign right here, it's a negative. So I'm going to rewrite this as plus a negative. And now when I group, I'm going to group these two terms together, and I'm going to group that negative inside. It's imperative that that plus sign stays in between the two groups. If it doesn't, this becomes a multiplication problem, and it's not a multiplication problem. It's an addition problem. All right, so step 3 says, hey, let's take out my GCFs. So if I look at my first group, 35xy and 5x, I see that they both have a 5 and an x in common, so I'm going to take out a 5x. So when I take out that 5x, 35 divided by 5 is 7. The x is reduced down to 1 and leave me with a y, minus 5x over 5x, those reduce to 1, so I have 7y minus 1, and then I have a plus. Anytime you can factor out a negative, go ahead and factor out a negative. So in reality, it's going to take this plus, and we are going to factor out a negative, so I'm going to factor out a negative 8 out of the second part. So these two terms both have a negative 8 in common. So negative 56 divided by negative 8 is positive 7, and I'm going to bring that y down. And a positive 8 divided by a negative 8 reduces to negative 1. Step 4 says, all right, let's look. Do I have anything in my two terms in common? So here's term 1, here's term 2. If they have anything in common, you're going to highlight whatever they have in common. So here we both have a 7y in common, 7y minus 1 in common. So I am going to GCF a 7y minus 1, which means I take a 7y minus 1 from here. I take a 7y minus 1 from here. When you do that, you are setting yourself up. All of these reduce down to 1, and then you bring down whatever you have left, which in this case is 5x minus 8. I'm just going to double distribute this. This should be your answer, and we're going to check it and make sure. 7y times 5x is 35xy. 7y times negative 8 is negative 56y. Negative 1 times 5x is minus 5x. And negative 1 times negative 8 is positive 8. So if we compare that to the original problem, it's not written in the same order, but it is a matching polynomial. Therefore, I have matched my problem that I started with, which means I have factored this polynomial correctly. All right, let's take the polynomial 3n cubed minus 4n squared plus 9n minus 12. Step 1, take out your GCF. I do not see a GCF, so I'm just going to rewrite my polynomial. 3n cubed minus 4n squared plus 9n minus 12. So now I'm going to put my brackets in. So step 2 is the grouping step. So I'm going to take and I'm going to group my first two terms. This is a positive, so that's good. It's going to stay right where it's at. And I'm going to group my second two terms. Now I look at my two terms and I'm going to take the greatest common factor out of each of these terms. So I look at 3n cubed and 4n squared, and they both have an n squared in common. So I'm going to take out an n squared. So when I do that, 3n cubed divided by n squared leaves me with a 3 and an n. N squared over n squared reduces to 1 and leaves me with a minus 4. I bring the plus sign down. 9n minus 12. 9 and 12 both have a 3 in common, so I'm going to GCF a 3. So I will bring a 3 out front. 9n divided by 3 is 3n. 12 divided by 3 is 4, and I will bring the negative sign down. The next step says, all right, we have two terms. So let's underline our two terms, term 1, term 2. I have to determine if the two terms have anything in common. If they do, which we're lucky right here because they do. Oh, that's not the right marker, so hold on, let me fix that. So we had you're highlighting right now. So we have 3n minus 4. So now if we look at my two terms, I have a 3n minus 4 here and a 3n minus 4 here. So I'm going to factor out a GCF of 3n minus 4. And this step is pretty deliberate. At this point, if you don't have a greatest common factor in these two terms, then you've probably done something wrong. So these are going to reduce down to 1 and leave me with the n squared. These reduce down to 1 and leave you with a 3. If you have done everything correctly, then this should be your factored polynomial. And again, you can check it using the double distributive property, or you can check it using the box method. I don't really care, but one way or another, you definitely need to check this polynomial. So here we have 3n cubed minus 4n squared plus 9n minus 12. And that actually matches the original polynomial up here. So I know that I have the correct answer, and we can move forward from there. I keep forgetting these last two steps, but they're on your front note card. All right, so our last example is 40xy minus 30x minus 100y plus 75. So I'm going to check for my greatest common factor, and I realize that we have a GCF of 5, so I'm going to GCF out of 5, which leaves me with 8xy. 30 divided by 5 is 6x. Here, my third term is negative, so I'm going to write that as plus a negative. 100 divided by 5 is 20y, and then 75 divided by 5 is 15. So step 2 always says, all right, let's take these four terms and let's group the first two terms together. And let's group the second two terms together. And remember, this always needs to be a plus sign right here. Don't ever include that plus sign inside any of your parentheses. Step 3 says take the greatest common factor of each group. So as always, this 5 is going to come down in every single step. So I'm going to take the greatest common factor. So if I look at each of these two terms, I have an 8xy and a 6x. So 8 and 6 have a 2 in common, and both terms have an x in common. So I'm going to GCF a 2x out of each of those terms. And when I do this, 8 divided by 2 is 4. The x is reduced to 1, and I'm left with the y. 6 divided by 2 is 3. The x is reduced to 1, and I have 4x minus 3. If I look at my second binomial, I have a negative 20y and a positive 15. So those actually have a GCF of negative 5. Whenever you have a negative in front of this first term in the second binomial, or in either binomial really, you need to factor out the negative. So no big deal. I'm just going to factor out a negative 5. So when I look at this, negative 20y divided by negative 5 is positive 4y. Positive 15 divided by negative 5 is minus 3. Close my square bracket. So step 4 says, all right, we now have two terms. Underline term 1, underline term 2. This 5 is going to come down. So now I say, okay, if there's anything in common, I'm going to highlight it. So I look at term 1, I see a 4y minus 3. I look at term 2, there's a 4y minus 3. So after you highlight it, this becomes your greatest common factor. So I'm going to GCF out the 4y, I'm going to GCF out the 4y minus 3. And I'm going to take a 4y minus 3 out of here. And I'm going to take a 4y minus 3 out of here. Since I have matching binomials here and matching binomials here, those reduce to 1. And that leaves me with my second binomial, 2x minus 5. At this point, this is my answer. And if you want to check, you can do the double distributive property. So multiply, multiply. So we have 8xy minus 20y. And then you're going to multiply here and multiply here. So minus 6x plus 15. So if I look at my polynomial, this is really all times 5. So now if I distribute the 5, I have 40xy minus 100y minus 30x plus 75. And other than the fact my middle two terms are switched, which is not a big deal based on the addition properties, that matches my original problem, so it looks like I am good to go. All right, you have an assignment out of your packet. If you need to look at the steps on the front of your note card, please make sure you do that. Otherwise, be neat, show your work, and don't skip steps. This is very much a process. It's very procedural, and if you do it the same way every time, it will continue to get easier, and it will make tomorrow's lesson significantly easier. Have a great night.